is negative infinity to infinity. What about your range?
0.
Okay, hard bracket, soft bracket, what do we? Okay. You never get all the way to the x-axis with this graph. It approaches it, but it never crosses it. So how many x-intercepts are there? There are 0 x-intercepts. And what's your y-intercept? So the 0.01. All right, what would you call the x-axis? What is it? Yeah, horizontal asymptote. And you see that asymptote as x is approaching negative infinity. I mean, it's the whole part of your graph, but it's telling you about the left end behavior of your graph. Does that make sense? Okay. All right, and your graph is always going to have the points 0, 1, 1, comma, a. So when you're graphing these for me, like, I need 2 points and an asymptote, and that's it. As long as your shape is somewhat believable, okay? You don't have to plot like 10 points with this. And smooth and continuous, very good. That's what your graph is. Okay. We are actually going to jump down. And let's graph a few. My grid looks terrible. Is that what your grid looks like, or is yours nicer? Oh, yours is nice. Okay, good.
It's small though.
It is small. And again, I'm plugging these points in here. And guys, if you think about it, your 2 points here, when we have a different coefficient, so 0, 1 is always going to be there, and then 1 comma, you can do a times b if you've got a different value going on there. And then you're going to have to account for your shifting up, down, left, right, all of that. We're not going to do all of these. Let's do number 2 first. Did you just ask if Iowa was a state? Yes. Recorded forever. Jonathan didn't know that Iowa was a state. So guys, there's a couple ways you can go about graphing something like number 2. You can think about if it was just y equals 3 to the x, what would 2 points on your graph be? 0, 1, and 1 comma 3, whatever your a is, okay? Now, things are happening to those points. We have a reflection, we have a stretch, and we have a shift left 2, right? Okay? So let's think about just doing that to those points. So the negative 2 out in front, does that affect your x or your y? Y. What does it do to your y values? Multiplies them by negative 2, right? So we would have the new point something negative 2, something negative 6, right? Why am I leaving that blank? Why am I just saying something? Left 2, but yes. Yes. So I have to go left 2. So instead of at 0, where am I going to be? Negative 2. And instead of at 1, where am I going to be? Negative 1. So those are my actual points for my graph. So negative 1, negative 3. So you still have your asymptote there on the x-axis, because we didn't shift up or down any. That is so bad. Let me go try that. And guys, don't be scared to let it cross. I mean, it obviously is going to cross your y-axis, but don't think that there's a vertical asymptote going on here as well, because there's not with your exponential graphs. Okay, does that make sense? You can also, if you want to, you could absolutely sketch these points. I'll do it super small. So I know I've got 0, 1, 3. That's essentially your parent graph. And then you're multiplying by -2 and shifting left. Okay? This isn't too foreign to you, is it? Okay. So let's just do number 3. You guys try that one. How are we doing, guys? Not us yet. There's always a horizontal asymptote with these. Yeah. And it's usually the x-axis unless you have a vertical shift. All right, guys. So let me walk you through the progression of this in case you were stuck at all. I mean, this is kind of throwing a little bit of everything at you. I would start by thinking about this being the equation y equals 1/2 to the x. So like I'm just taking this little basic part that we have. That would give me the point 0, 1, 1 comma half, right? Are we okay with that? Yeah, can you see that? So then I'm going to start doing all the transformations. You have to do your reflections before you do the shifting. So I'm going to go ahead and multiply by -3 first. Again, that affects your y values, right? You're with me there? So that's going to give me these points, 0, -3, and 1, -3/2. Okay? Then I've got two shifts going on. I have to go left 2 and I have to go up 1. So left 2, that just means subtract 2 from your x value. So 0 minus 2 is -2. 1 minus 2 is -1. Okay? And then plus 1, that means add 1 to your y value. So -3 plus 1 is -2. -3/2 plus 1 is -1/2. This also means that your horizontal asymptote is no longer at 0. It was shifted up to 1. This is what your graph is. Okay, how many got there? Yes, okay. Alright, so we're doing okay with that? Let's try to solve some exponential equations then. When you're solving exponential equations, you want to make the bases match. Okay? So if I look at the first one, 3 to the x plus 1 equals 81. 3, I really don't want to change, like you always want to go to the smaller base, so 3 is definitely going to be the smallest base I can use, so I'm going to leave that alone. And then on the other side, is 3 to some power equal to 81? Fourth, okay. Once the bases are the same, it becomes very simple. Then it's just set the exponents equal. And I get x equals 3. Okay? Alright, let's do number 2 together, because I'm throwing some e's in there for you. You guys remember e? It's just a number, okay? It's like pi, don't panic. Alright, so I'm going to leave this -x² alone. And then this is just testing to see if you remember your exponent rules. So e to the x quantity squared, that is e to the 2x. Okay. And then 1 over e, do you guys see how that's e to the -1? Yes? Okay. When I'm multiplying and I have the same base, what can I do with my exponents? Add them. So I now have e to the -x² equals e to the 2x minus 1. With me there? So -x² equals 2x minus 1. So I move that x² over. Can we factor? We cannot factor. So, should we practice completing the square again?
No.
Yes, we should. Alright, so I'm going to send the 1 over here. And do you guys like it better on the left? My brain just likes seeing it better like this. I don't know why, it's just repetition, I guess. Alright, so what am I going to be adding to both sides of my equation?
4.
Yeah, not quite 4. We go at 1 over... What? Yeah, we go 105. Yeah, in like 5 seconds. So what am I actually adding to both sides? 1. Okay, so this leaves me with x plus 1 quantity squared equals 2. X plus 1 equals plus or minus root 2. So x equals -1 plus or minus root 2. Woo! All right, guys. Let's pause there, go to lunch. Alright guys, are you getting x equals 0 for number 3? Okay. And what base did you guys pick for number 4? I was like, ooh, that would be interesting. Okay, good. Alright, are you okay with 3/4 for x in the last one? Alright, so are these pretty easy? Yes? Okay. Anybody need more time? What, Sarah? Sorry. You good? Okay. Alright guys, so now we're going to talk about the number E. Right now all you need to know is that it's 2.718. In calculus you'll learn a lot more about where E comes from. It has to do with limits. Right now this is all you need to know about it. So, what we use it for often is the base of a logarithm. If it's a log with base E, do you guys remember what that's called? Natural log, yeah, so ln. And then we're going to do a lot of just turning log equations into exponential and vice versa. So you just need to remember that E is your base if it's a natural log. So let's just start going through some of these to see what you guys remember from last year. So number one here, if I'm going to rewrite the log expression as an exponential expression, what would it be? Yeah, so it's always the base to that exponent equals 7 squared equals 49. And that makes sense, right? 7 squared is 49. So number two, that's called a common log when the base isn't listed. What is the base? 10. So this is 10 to the third equals 1,000. Okay with that? Alright, so number three, again, that's natural log. Your base is not listed. What is your base? No. E. So the base is E, that's not written in there. So E squared equals E squared. Okay. And what about number four? Okay. Easy. Okay. Now we're going to actually solve. So how would you write number one in the next section there as an exponential equation? Yep. So 25 equals x. Okay with that? Alright. So number two, you're thinking 2 to some power is 8. So what does y have to be? 3. Alright, number three, a squared is 16. So what does a have to be? 4. Alright, and then the last one there, you are thinking 3 to what power is 81. So what does y have to be? 4. Okay. We're okay with that section? Yes. No, because you can't have a negative base for these logs. Alright. So number 9 there. I'm thinking 8 cubed equals x. So you can either leave it as 8 cubed, or if you really want to tell me what 8 cubed is. Is it possible? Yeah, 64 times 8. Alright, this one's going to be a to the third equals 64, so what to the third power is 64? 4. 3 to the 0 is x, so what's x? 1. And then your last one there, 9 to the 1/2 is x, so what does that mean? 3. Everybody remember an exponent of 1/2, that's square root? Alright. We're going quickly, but you're fine, right? Okay? Anybody not? Anybody waving the white flag? We're doing okay? Alright. Okay, so the next section, it says evaluate the logarithm. You're basically thinking through solving the log equation, it's just not written as an equation. So what you have to think about at number one is 4 to what power is 64? 3. 3 to what power is 1 over 81? Negative 4. 5 to what power is 5 to the 6th? 6, yeah. And then 10 to what power is 1? 0. Okay? Alright, turn the page. Now we get to do some graphing, but with logs. really not bad. All right, guys, so I'm going to start by sketching an exponential graph because we know how to do that. I'm going to graph y equals 2 to the x. So I would have the point 0, 1, and 1, 2 on my graph, right? It would look something like this. Okay? Logarithms and exponentials are inverses of each other. What does it mean to be inverses? Okay, you switch your x and your y. What about graphically? What does it mean when things are inverses? Reflect over y equals x. So if I think about the line y equals x, I'm just mentally have that in there. And I flip these points. So 0, 1 becomes 1, 0, and 1, 2 becomes 2, 1. And my asymptote that was a horizontal asymptote, what kind of asymptote is it going to be now? Vertical. That is what my graph looks like. So if you remember with our exponential graph, we had the point 0, 1, and then we had 1a. So what do you think I now have with my log graph? 1, 0, and a 1. Good. Okay. All right, then let's think about our domain. Jonathan, what's our domain for just the purple graph up here, the log graph? 0 to infinity. And what about your range? Do you guys see how that's just flipped from your exponential graph? Which should make sense again with them being inverses. All right, so now how many y-intercepts do we have with this one? 0. Yeah. And then what is your x-intercept? 1, 0. Okay. And then what kind of asymptote do we have this time? All right, you're always going to have the point 1, 0, and then a 1. And this graph is still smooth and continuous. Okay, guys, down here from the equation we're looking at, we definitely have the point 1, 0. We can fill in these little blanks. And I called it A1 up above just because I was doing the inverse of my exponential. What you're actually going to be looking for in the equation is the base. Okay, so we could call it B, 1 if we wanted to. Like that base right there is what you would be plugging in. And I would do it exactly how we did the exponentials. I would think about sort of the basic graph and then do any reflections or stretches and then do your shifts after that. So let's do number 1 together down here. So again, your graph looks prettier than mine, right? All right, so what I am going to think about graphing is the equation y equals log base 3 of x. So that means I would have the points 1, 0, and then base, 1, so in this case that would be 3, 1. So those are sort of like your parent graph, your base graph with log 3. Where are my points going then? Right 1, down 4. So that means I'm adding 1 to both my x values. So I'm going to get a 2, and I'm going to get a 4. And then what about my y values? What am I doing? Yep, so that's going to be -4 and -3. Okay, and then I would think about your asymptote as well here. Normally, it's a vertical asymptote right at x equals 0. Which way has that been shifted? To the right one also, right? So I would just sketch your asymptote first, so you don't lose it. And that'll help you when you go back and actually plot these points. So I've got the point 2, -4. Somewhere in there, you have better lines than I do. And then 4, -3. And then follow your asymptote. Yeah. 1. Yeah, because normally it's at 0, and so we've gone to the right one, so that's also going to go right. The up and down shift doesn't affect this asymptote at all. Okay. How do we feel about that? Yeah, Drew. There is not a horizontal asymptote with these. Yep, just think inverse from the exponential. That one had a horizontal asymptote, this has a vertical asymptote. Okay. All right, guys, so you try, let's do 2 and 4. Just because the numbers are a little nicer. You're ready, guys? Take a look at 2 and 4, and let's see how you did. We're doing okay with just thinking about, okay, parent graph points and then do our shifting? Okay. What do you mean? Oh, yeah, there hasn't been any sort of, like, vertical stretch with these. You could do either. Like, I could put, like, a 2 out here, and then that's going to stretch it. All right, let's solve some log equations. We are quickly running out of time here, guys. I believe we get out of here at 1:50 today, right? Yeah, we got 2 minutes, so let's solve a couple of these. All right, guys, so number one here, you start by turning it into an exponential equation. So that's going to be 3 squared equals 4x minus 7. From there, it is not hard. 9 equals 4x minus 7. Add your 7. So 16 equals 4x. X equals 4. When you're solving these, you just want to make sure that your answer actually works when you get, like if you were to plug it back into your equation, okay? Just think about parent graphs here for logs. Like your domain is only from 0 to infinity, right? Not including 0. So if you solve and it's giving you like a base that's -3, can you have log with a base of -3? No. Okay, so just make sure that you don't have any extraneous solutions as you go through these. None of the examples here in your notes have extraneous solutions, but that's okay. So we are not getting to the exponential growth and decay, the word problem stuff yet today. We will do it. Don't fret. Number 3. Yeah, guys, let's do number 3. When you have an e in your equation, you're going to want to take the natural log of both sides of your equation. So this is the natural log of e to the 2x equals the natural log of 5. So evaluate the left side of your equation there. Or, do you remember your rules? The exponents go in front. Do you remember that at all? Okay. Properties of logs, we'll get to that. What is the natural log of e? 1. 1. So this is really 2x equals natural log of 5. So x would equal natural log of 5 over 2. Okay? Sarah, what's your question? Could you have a base with -8? That's what, so yeah, just think about that stuff. Homework, guys. I don't have an assignment sheet right in front of me, so do what's on there unless it's an exponential growth or decay word problem, then obviously don't do those yet. The answer to number 4, -1.